Hey everybody, and welcome to our lesson on similar triangles. When we talk about similar triangles, we're talking about two triangles that are similar, meaning they have all their angles congruent. All the angles will be the same from one triangle to the next, and all the sides will be proportional. They will share the same relationship. We'll take a look at an example where that happens in just a minute. Basically, similar triangles look the same, but they could be different sizes. They're the same shape, but could be different sizes. One type of similarity is called angle-angle similarity. In a triangle, we know that all three angles add up to 180 degrees. So if we are given two angles and we're missing the third, we could always find that third angle knowing that fact. We can take the other two angles and add them together and then subtract that from 180 to find the missing angle. So since we know that fact, if we are given two triangles that have two of the same congruent angles, that third angle in each one is forced to be the same. All the angles have to add up to 180. So that's why when we're given two angles, we can state that the triangles have angle-angle similarity if they're congruent. Let's take a look at an example of this. So here's two triangles, and we are given some information in this. The angle on the small triangle at the top here is 41, and then the bottom right corner is 39. Okay, and then over here in the right-hand triangle, we're given this one, 100, and the bottom right 39. We can see that the 39 degrees matches, okay? But how about the other two? Would these triangles be similar? Remember, all the angles have to be congruent and sides have to be proportional for this to be similar triangles. Take a look at the big triangle. If we are given 100 degrees and 39 degrees, and we want to find this other missing angle up here to see that it matches. Well, 100 plus 39 gives us 139, and then if I subtract that from 180, I am going to get 41 degrees. So right now I know that two of the angles in these triangles match, and therefore the third must match. So these two triangles are similar by angle-angle similarity. In fact, all three angles are congruent. Okay, another way that we can state similarity is by finding out that the sides are proportional. Proportional sides means that each triangle's side lengths have the same relationship from one to the next. So let's take a look at an example of that. I've got a larger triangle and a smaller triangle here. And what I'm going to do is I'm going to take a look at some corresponding sides and find out the relationship that they have and see that all of them match. Okay, so I've got the big side over here of 10, and then the smaller side is 5, and those two sides give us a relationship of 1 to 2. 5 to 10 is a relationship of 1 to 2. So if I find that all three sides share this relationship, that means all sides are proportional. So let's check it out. Let's take the right-hand side, and that one also from small to big is again 5 to 10. Okay, so that is a 1 to 2 relationship. Let's take a look at the bottom. Small to big, I've got 6 to 12, which is again a relationship of 1 to 2. So since all of these sides from small to big have a relationship of 1 to 2, then the sides are proportional and these triangles are similar. Alright, so let's practice what we've learned. We need to find out if these triangles are similar, and if they are, we're going to find all the missing pieces. Alright, so first of all, we can see that we're given two angles down here, corresponding angles, and we can see that they match exactly. They're congruent in each corresponding spot. So remember, by angle-angle similarity, I can go ahead and say that these triangles are similar. So what we need to do is find that third angle. So we are going to add 75 plus 84 and then subtract that from 180. Okay, so let's take some practice space over here. 75 plus 84. 159. going to take 180 minus 159. And I'm going to have 21. So that last missing angle is 21 degrees. Let's go fill that in. I know they match because we already discussed that 2 of them match, therefore that third one is forced to match. They all have to add up to 180. Alright, and since we know that they're similar, their sides are going to be proportional, so let's take the 2 side lengths that were given on the small and the large triangle. We've got 2 for small, 6 for large. So 2 to 6 is a relationship of 1 to 3. I'm just reducing that fraction. So all the sides should follow that same relationship. So let's take our left-hand side. This 5 should have a relationship of 1 to 3 with the larger side. So the larger one should be 3 times as big as the 5. So 5 times 3 gives us what? 5 times 3 gives us 15. So let's go fill that in on our triangle. All right, and we just have one more side to find. We've got our right-hand side here. We're given the large side this time. We're given this 9. So following the 1 to 3 relationship from small to large, the smaller side should be multiplied by 3 to give us 9. So what number multiplies by 3 to give us 9? Let's take a look. Some number times 3 gives us 9. And we know that number to be 3, so we can go fill that in. Alright, so we're going to scan through and make sure we found all our missing sides and angles, knowing that these triangles are similar, and we have. Check our work if we need to. And that concludes our lesson on triangle similarity.